This is the first section in the book on sequences, so we will revisit some of the ideas that we've done. Today is not talking specifically about arithmetic or geometric. It's talking about sequences in general. And we're going to look at sigma notation, and we're going to look at using the calculator in sequence mode just a little bit. So make sure you have a calculator. And I'm going to get started. So our learning targets today are to be able to generate the terms of a sequence given either a recursive or explicit formula, determine if it's arithmetic, geometric, or neither. We're going to talk about the words convergent and divergent, and graphing the terms of a sequence, which will help us determine convergent and divergent. And then we're going to look at that sigma or summation notation. So this should be review of the vocabulary we did last week. In math, a sequence is an ordered list of numbers. Each number is called a term. A finite sequence would mean that it ends at a certain point. An infinite sequence would have the ... A sub n denotes the nth term. Explicit, when we have an n in it, okay? An explicit formula gives the nth term a sub n as a function of n. All that should be familiar. Big deal today, remember that not all sequences are arithmetic or geometric. Okay? Can you see okay, Dakota? Past that crazy chair. Sequences can also be defined recursively. That is when you give one or more of the first few terms and then define the following terms based on those previous terms. We have been using a sub n minus 1 as the term immediately before a sub n. You could use a sub n minus 2, which would just mean two terms before that. Okay, it's called a recursive formula when you use that. This is all review, and it's at the top of your sheet here. So we're going to start with example 1. Is this an explicit or recursive formula? Yes, this is explicit because it just has n in it. So if you want the sixth term, you just put a 6 in. So you'd get 1 over 2 times 6. And the big fraction bar always means everything below it stays together on the bottom. So we'd have 1/12 plus 2, which would be 2 and 1/12, or 25/12. If you did a math enter. Is that a decimal that ends? I feel like 1/12 is going to be repeating. Yeah, it's a repeating decimal, right? So the exact form would be to just leave it as a fraction. All right, find the third term of this sequence, explicit or recursive? Yeah, it has an a sub n minus 1, so this makes it recursive. And then the easiest way, if they only want the third term then, is just to plug in the terms. So the first term is 9. If you plug the 9 in here, this is take the opposite of a sub n minus 1. So you'd have the opposite of 9 divided by 3, which would be what? -3, we good? Then put that term in up here. So you would have the opposite of -3 divided by 3, which would become 1. And then that's all they wanted was the third term. It's basically just taking and dividing by -3, right? Any questions about that? Keaton, can you find this packet? You can also find terms to sequences using your calculator. So this is going to be several different ways that we can do that. There's some old school ways. If they give us, I don't honestly hardly ever use this method, but you can use on your calculator. Everybody got one? So we're going to go to second stat, and to the right is a sequence. The operations include a sequence, which is number 5. Here you can put in any kind of a formula. I think the one on your sheet says try 3x plus 2, comma x, comma 1, comma 10. Let's see, I need to go. This is in function mode. It will actually work in any mode, but function mode would give you the x. So if I go here to sequence, and what did it say again? 3x plus 2, and it wants the first 10 terms. So 3x plus 2. Oh, it's not, okay. Then you would need comma x, comma 1, comma 10 if you had the old calculators. This means it's in terms of x, and I want the first 10 terms, and then when you hit enter, it would give you the first 10 terms. If you have the new calculator, it should bring you up the wizard, so you would just say 3x plus 2, where the variable was x, and I want terms 1 through 10. Oops, whoops, oops, oops. You don't really need to put in step. It's going to assume you want it to count by ones. If you wanted to count by something else, you'd put in step. Okay, questions on that? That same thing will work if you're in sequence mode, polar mode, doesn't matter. It's just putting in values. And what kind of a formula was that, guys? That is explicit, okay? That only works for explicit. Another way you could do is if you are in function mode, you could just go and type in 3x plus 2 as a graph, and then if you have your table set to count by ones, you could say start at 1 counting by ones, and then when you went to the table, it would give you the sequence, right? Anybody need me to go back over any of that? Y equals, put in, go to the table set, say I want it to start at 1 counting by ones, and then go look at your table, and there would be your sequence. Again, that only works when you have an explicit formula. So those are the first two things here. The third one, you can put your calculator in sequence mode, and that's going to give you some crazy business. Please circle this on your notes, guys, or make a big star here or something. This tells you what all of these mean, okay? I don't like the order this is given in. Again, who's surprised? Hofbauer never is happy with what the calculator does, but, or the order. It didn't let me design it. N min, okay, stands for the minimum term number. Term number, not the value, the term number. It's usually 0 or 1. I think it defaults to 1. We'll talk eventually when we do some application word problems why we might want a 0 there. If you go down a line, it says U sub n, and this is where you can put in a formula. You can put in explicit or recursive here. Then the third line says U sub n min. This means what is U sub 1. So you have to enter the first term here if you're using a recursive sequence. If it's explicit, you can leave that blank. But that's what it's telling you over here. For this sequence, if we wanted, we could go, okay, so let me go back to the calculator. First of all, if you go to mode and you scroll down and you go all the way over to sequence. Everybody good? Mode, sequence. Okay, then if you go to your Y equals button, you have some crazy business in here. Okay, so n min again is saying it's going to start with the first term. The second thing it wants here is the formula. This is nice. Does yours, the older calculators just say U sub n min here, right? Does yours say U sub 1, U sub 2? No? Okay. I might be able to upgrade your operating system since you do have one of these. But if it just says u sub n min, it just means the first term, okay? And you can write, we're going to always use this one up here in terms of n, not in terms of n plus 1, n minus n plus 2. All right, so I'm just curious, what happens if I change this to 0? Oh, interesting, it does change this to 0 and 1. Older calculator didn't do that, or even the older operating system. All right, so for the one we're doing today, we were just putting the sequence that's explicit, so it's going to be 3n plus 2. Okay, and it's explicit, so we don't need to put in a term 1 or a term 2. Everybody good? You could go to the table now, and it would have the sequence. Notice if you scroll back up, you get an error because it is defined as a sequence, not a function. Okay. You can also graph this. This is a sequence that's linear, so it, I believe, is going to give you a series of dots. It depends if you're in connected mode, though. I'm going to just do a zoom. This says how many terms do I want it to graph. Let's just do like 10. And I'm going to need it to have, I don't know how high it needs to go. Well, mine is connecting them. Is yours connecting them? Let's see. Try this. Yeah, these are the terms. So term 1, term 2, term 3, term 4 are graphed here. Anybody need me to go back over something? So for mode, I put it in dot thick, or just if you have one that says connected, choose the one that's not connected. Who needs help? All right. Is this approaching a particular number, or as I put in more and more terms, it's just going to keep going, right? So this is called a divergent sequence. We're going to get to that vocabulary in a minute, but it's just approaching infinity, basically, and that's not the definition of convergent. All right. What are we supposed to do next? So we're supposed to maybe try using the calculator to find these. If I go back here, oh, I guess I don't have one. Okay, we have to talk about this when you have a recursive sequence. The very specific way you have to use that on the calculator. But let's do this first one first. I wouldn't even use a calculator because well, maybe to find the number, but not to use the sequence mode. It just wants the 8th term. So the easiest way would just be to do what? Yeah, this is explicit, so just plug in 8 in. If you want to use the calculator, just for practice, go back to y equals. It is an explicit formula. It's n cubed minus 1 all divided by 2, so I would put parenthesis n to the 3rd. Then what was it, guys? Minus 1, close parenthesis, oh, that's not a 1/2 power. Close parenthesis divided by 2. Is that what, do I have it in right? Okay. And then if you go to the table, the 8th term is 255.5. Okay. You can scroll down and make sure that's exact if you wanted, because it would tell you at the bottom. I don't know that you can do a math enter at that point. I don't think so. Any questions on that? Like I said, I would have just done that without sequence mode. So you can write down the answer was, what was it again, guys? 255.5? Or no? Anybody awake? Was that the right answer? 255.5. Okay. This is a recursive sequence, okay? So if we're going to type in a recursive sequence, it's very specific what we have to do. Please pay attention because this is the first time we've done this, okay? You go to your y equals key, clear this guy out. Now, the first term is called the first term, so we're going to put a 1 here. And then you can skip this and go down here, and yours either says u sub n min or u sub 1. And we're supposed to put in this 7 right here. And then we're going to go back up here and put the sequence in. Everybody ready to try this? The u that you're going to use, because these all use, well, this is u, this is v, okay? But the u you're going to use is this u above the 7. So second 7. And then we're going to put in, oh, it's supposed to have a 2 in front of that, my bad. 2 u sub n minus 1 plus 5. I'll go back here and put a 2. And then second 7, parenthesis, n minus 1, close parenthesis, and what was the rest of it? Plus 5. Again, I wouldn't have done this on a calculator probably if I had to do this for a question. But if you go to the table now, it will list the terms. And they wanted us to find the fourth term, so we got 91. Yes? Anybody having trouble? Okay. Because it only wants the fourth, I mean, if it wanted the 22nd term, I would do what we just did. But because it only wants the fourth term, I would have just put it down 7 and then put the 7 in here. That would have been 14 plus 5 is 19. Then put the 19 in here. 2 times 19 would be 38 plus 5 would be 43. Then 2 times 43 would be 86 plus 5 would be 91, and I have the fourth term. I just think that would have, and you could have done it on your calculator home screen, but that would have been faster than trying to remember how to put it in sequence mode. Any question there? When I keyed the quiz, I didn't use sequence mode at all. So the first term of a sequence is usually denoted as a sub 0. The first term is occasionally denoted as a sub 0. When this occurs, the domain of the function is not the set of whole numbers. It starts with 0 instead of 1. We will talk about that much later, Thursday maybe. All right. Way long time ago, we started talking about what a graph approaches, way back in the first chapter. And we talked vaguely about it as a limit, but mostly we just talked about it as the end behavior. As a function, an infinite sequence may also have a limit. If it has a limit or it approaches a particular number, then it is said to converge. If not, it is said to diverge. So diverge does not mean that it goes apart or does anything crazy. It just means it's not approaching a singular number. That number that it's approaching cannot be positive or negative infinity. It has to all go towards 1 or 0 or something. Okay? If an explicit formula for a sequence is known, you can enter it and graph it, okay, to determine whether it is convergent or divergent. So this, first of all, I would have looked at this sequence and said they're going to keep subtracting 3, right? Everybody see that? If they keep subtracting 3, is it ever going to approach a single number? It's eventually going to become negative and just keep going more and more and more negative. So they graphed it, it's linear, it's divergent. This sequence is they started with 36 and then they're multiplying by negative 1/2. Now because it's negative, it's going to go positive, negative, positive, negative, positive, negative, back and forth. But if you keep taking half of something, it's going to get tinier and tinier and tinier. So it's eventually going to approach what? 0. So this is a convergent sequence. This is a crazy one. if we were to type this in, we would get this crazy graph. It does not approach a single number, okay? It bounces back and forth between positive and negative, but it does not approach a single number. You could say the top is approaching 0.25 and the bottom is approaching negative 0.25, but it's not one particular value, so it is divergent. Okay, can we logic through this without graphing? If we need to, we can graph, but what's happening here? 64 divided by 2 one time would be 32. The next term would be 64 divided by 2 times 2, or 4, which would be 16. The next term would be 64 divided by 2 times 3, which would be 64 over 6, or 8/3. 64 over 4. I did that right, didn't I? Is this going to become negative? Is it going to approach a single number? Let me do another one. 64 over 2 times 4. Well, 2 times 4 is 8. Is this one wrong? What's 64 divided by 6? Thank you. I don't know, because my brain is not working. So this is getting smaller and smaller, yes? If we graph it, we'd have to be careful to put parentheses around the 2n. But we would put in, again, we don't want the first term to be 7. It's 64 divided by just 2n. Thanks. And then if we were to look at the list, it's getting smaller and smaller and smaller. If we were to graph it, here's what's happening. Is that going to approach a certain number? What's it going to approach? 0. Okay, so this one is convergent. Okay, the next one is not an explicit formula, but if we put numbers in, the first number is what, guys? First term? Then what are we supposed to do? Plus 4, whoops, that's a 17, plus 4. Is that going to approach a particular number? It's going to keep growing. So this is also what, or this is what? Yeah, divergent, okay? This one, if you put a 1 in there, what will you get? Negative 1 to the first would be negative 1, right? Times 3 would be negative 3. If you put a 2 in there, square negative 1, you get positive 1. Put a 3 in there, negative 1 to the third is negative 1. It's not a very exciting sequence, but is it going to approach a single number? Yeah, it's going to be one of those that bounces back and forth between 2 separate numbers, so it's divergent. All right, you have these. The first one, what's happening? It is getting smaller. Can you tell, is it going to become negative? Let's see, they subtracted 2, 4, 6. So I'm thinking we'd have 0, negative 10, negative 22, right? It's subtracting 2, then 4, then 6, then 8, then 10, then 12. But there's no reason for it to stop and get close to 0. So this is still divergent. Basically, guys, this sequence pretty much has to be geometric to be convergent, and this is not. All right, we can try this one in the calculator. You will need extra parentheses around the denominator, but it'll give you a little more calculator practice. We're going to start with term 1, but it is an explicit formula. Did it have -1 to the n on the top? Is that what it had, guys? And then it was divided by the quantity. We need parentheses around the bottom, 2n minus 1. Probably should have done a few terms by hand just to make sure that this is working. But if we look at the table, positive, positive, or negative, positive, yes. So it's bouncing back and forth. Does that mean it has to be divergent if it's bouncing back and forth? Not necessarily, no. If you scroll down, what is happening? Yeah, it's getting closer and closer to what? 0. If you attempt to graph this, it will depend what you have your window set on. I don't know. If I try to zoom standard, would it do anything exciting? It's hard to tell here, but it's bouncing back and forth. I think I'd have to make my Y window pretty small to actually see what's going on. Like -2 to 2 or something. But it is getting closer and closer to 0. So it's convergent. On the quiz, I gave you a sequence like this, where it's just a list of numbers, okay? If it is, the only way it's going to be convergent is if it's getting closer and closer to a particular number. It does not keep going. It would have to be geometric. All right, a series, this is the vocabulary, is the indicated sum of all the terms of a sequence. So this is the series. If this was the sequence, this is what the word series is called. It's finite, means you want like the first 5 terms. Infinite means it has the ... Okay? Like sequences, series can be infinite or finite, but it is the sum. When you want them to add up, it's called a series. The nth partial sum is denoted like this, and this is the formula we're going to use starting tomorrow. We're going to use summation formulas for arithmetic and geometric sequences. The n tells you how many, so that if it says this, it means it wants the sum of the first 3 terms, which is also called the third partial sum. So when they use that vocabulary, don't get all confused. Here it says find the 4th partial sum of this sequence. It just means find the sum of the first 4 terms, okay? So put in a 1, 2, 3, 4, add them up. So an infinite sequence, ... infinite series, they're added. The sequence of first 4 partial sums, they added the first term, the first 2, the first 3, the first 4. I'm not going to use that vocabulary, okay? Some infinite series do not have sums. For an infinite series to have a fixed sum, it had to be converging to 0, okay? We'll talk more about that later. Series are often more conveniently denoted using sigma notation. Okay, we used to have to do these all by hand, but your calculator now will do this summation notation if you have a newer calculator. Even the old ones do, it's just a little bit different, okay? But this is called a sigma notation. It tells you what to start with at the bottom, and it does not have to be 1. I could say I want to add up only terms 5 through 7, and it would look like that, okay? Most often starts with 1. And then it gives you the formula for the sequence here, so 2n plus 5. So I want to put a 5, a 6, and a 7 in, and then add those 3 answers up, which is what my example would mean. All right, so you have this, and it says find the 7th partial sum, and it does not have sigma notation. We could try to write an equation, but since they give us the first 4 terms, wouldn't it be faster to just find 5, 6, and 7 and then add them all up? I don't want to teach you an ineffective method, okay? What did they do here, guys? they added 12, then they added 11, then they added 10. Is this arithmetic or geometric? It's neither, right? So it would be a pain in the neck to try to write a formula for this. So let's just figure out if we can find the next 3 terms and then add them up, because it wants 7, the sum of 7. So if we added 9, we'd have what? We added 8, and we added 7. Now do we have 7 terms? Term 1, 2, 3, 4, 5, 6, 7. So we just need to add those terms up, and we'll have the answer. The sum of the first 7 terms is 3, 4, 18, 35, 43, 53, 63 maybe? That's probably wrong. Is that right? So the big thing I want you to get out of that is just understanding 7th partial sum means the sum of the first 7 terms. Everybody good with that vocabulary now? All right. Now, this is summation notation. So it says put in the numbers 1 through 5, and then this sigma means add up those answers. So they put in the numbers 1 through 5 and got these numbers out, and then they summed them and got 45. There's 2 ways to do this, several ways to do this on your calculator. Here's an infinite sequence, so it says to infinity. I did not put that on the quiz. But if you kept putting a number in here, so it's 7 divided by 10, and then it's 7 divided by 10 squared, and then it's 7 divided by 10 cubed, that's going to get smaller and smaller and smaller, right? Okay, so they said eventually if you add up 0.7, 0.07, 0.07, 007, etc., you'd get 0.777 or 7/9. That's an infinite geometric sequence where you're finding the series, the sum of it. All right, you have example 5. I'm going to show you 2 ways to do this on the calculator. Are you ready to try this? The first is kind of the old school method. Go back to second stat. Everybody try this, please. Second stat. Arrow over twice. What are we trying to find that's on this screen? The sum, right? So it was second stat, arrow to the right twice, and we want the sum. Let me erase this also. Okay. Then we're going to go back to second stat, but arrow to the right only once. And we're going to say the sum of the sequence, number 5. Now, the sequence we're doing for this question is 2 to the nth divided by 4. So you could put 2 to the n power and then divided by 4. I'm a little concerned about that. I'm going to put a parenthesis here just in case, because it's not using that little box. So I'm going to do this. All right. And then the second thing I want to know is what variable you're using. Well, I'm using n, so I'm going to just hit this key again. And we wanted what your worksheet says, terms 1 through 4. Do you see that sigma notation says 1 through 4? So you're going to put in here a 1, enter 4, and then enter down here, and you will get this crazy business. If you had the older calculator, you would just put in the commas. Everybody getting it to work with the older ones or not? You just need the commas. I wouldn't have done that. If it said the sum of the first 75 terms, I might have used the calculator. Okay, I would have used the calculator. But when it says find the sum of the first 4 terms, couldn't you just put in a 1, a 2, a 3, a 4, and then add them up? Probably would have been faster than trying to remember where all those buttons are. But even easier, okay, we got 7.5. Even easier, your calculator, if you have one of mine or a newer one, does do the summation notation. You just go to math. I would arrow up instead of down because it's way down here at the bottom. It's O, or 0, I mean, sorry. And it's summation, and then you hit enter, and then you can type in all these little boxes. This wants a variable, so I'm just going to use n. And we wanted term 1 to 4. And then in this little box here, I need 2 to the nth divided by 4, and make sure the divided by 4 is not up in the... Yes? No? Anybody need help getting it? It is one other place that has a shortcut, and I don't know where it is. Alpha 2 would be my guess. Yes. Alpha window is where the shortcut is here as well. If you'd gone down to number 2, it offers you the same thing, okay? I don't think that's much of a shortcut personally. Math up arrow is pretty short. All right, so those are the 2 options other than just typing in 1 through 4. So we got 7.5. All right, so find the 6th partial sum here. You want me to do it on the calculator? You could do sum sequence. It would be 4n minus 1, comma n, comma 1, comma 6, because it wants the first 6 terms. If you're not confident, you could just put in a 1 through 6. If you put in a 1, you get 4 minus 1 is 3. You put in a 2, you get 8 minus 1 is 7. Put in a 3, you get 12 minus 1 is 11. I can tell it's going up by 4. And I'm supposed to find the sum of the first 6. So there's my list, and then I add them up. 26 times 3, 78 maybe? This is an intro to tomorrow's lesson. Can I tell you how I got 78 so fast? What is the sum of the first and last term? What is the sum of the second and second to the last term? 26. What's the sum of these two? Okay. The first, if it's arithmetic, that's the way it always works. So these two added up to 26, these two added up to 26, these two added up to 26, so 26 times 3 was 78. We'll learn more about that tomorrow. You could have also tried to use the sum notation. You could have said 1 through 6, 4n minus 1. I probably wouldn't have done that. Any questions? Can you do these last two, though, using the sum notation real fast, number 6 and 7? Just go to your calculator. I'm going to just use the math, arrow up. The first one says term 3 through 7. Oh, interesting. Again, you could just put in 3, 4, 5, 6, 7 and be done with it. And 3 up arrow 7. What was the formula, guys? N squared minus 2. I got 125 for that one. Okay, and then 1 through 6. The next one. Where the formula is 3 times 1/2. Okay, you got to put this in an extra set of parentheses here because of this parentheses that come with it. So it's going to be 3, then another parenthesis, 1/2 to the, and I know some of you like to use the fraction-y thing. That's fine, it won't matter. N minus 2 is up here. And an older calculator, you would need another set of parentheses around the N minus 2. I got 11.8125. Is that a terminating decimal, ending. Yeah, it's not going all the way across the screen, so yeah, that would be exact. Or you could do a math enter, and it would do it. Any questions? Okay, so I'm just going to put this on here so people can see what we did. Number 9 says a vacuum pump removes 15% of the air from an air mattress on each stroke of its piston. The air mattress originally contained 20 liters of air before it starts. Okay, so write the first 3 terms representing the amount of air in liters that remain after each stroke. Is this after 1 stroke, guys? Yeah, that's the start. So, well, we might want to list 20. That's not the first term of the sequence. Okay, what is removes 15% though? This is a huge issue that we got to be good at. Do you remember when when we were doing exponential growth and decay? What are we multiplying here if it's removing 15%? Okay, but 1 minus, or all minus 15% is what? 85% or 0.85, or is this coming back to you guys? So we need to do 20 times 0.85 to figure out how much remains after 1 stroke. Somebody got that? 17. And after the next one, you'd multiply by 0.85 again. That's going to be a decimal. And then one more. Is that rounded? Okay. Write an explicit and recursive formula. Okay, so the first term is the previous term times 0.85, where the first term was 17. Or we could have said where a sub 0 is 20. Is that explicit or recursive? Yes. The explicit we'd have a little more trouble with, except that we've already done geometric sequences. So you could have said, I'm going to start at 17 and I'm going to multiply by 0.85 and minus 1 times. Is this going to converge or diverge, guys? What's going to eventually be left in there? They're taking the air out. How many liters of air is going to be left? You're taking out 15%, out 15%, out 15%, out 15%. They're going to get down to 0, right? You're going to get, it's going to converge to 0. All right. You are to do the circled problems on 5.5a. This looks like a lot, but it's really not at all, guys. This little section, it just gives you a graph and says, is this converging or diverging, okay? So these last few are just converging or diverging. It seriously will not take probably more than 10 minutes to do that assignment, so please get it done tonight. All on 5.5a.